Assalamualaikum and a very good morning. I wish to Doctor and all my group members. So we are from group 18. We will try to explain on our project, which the topic is to design for refrigerated container. So our group members consist of three members, which is me, AZIZI bin RAZI, Muhammad AL-BAIHAQI, and IHTIFAZUDDin. So now I will pass to my first member, which is IHTIFAZUDDin, to explain about the introduction.
Assalamualaikum. So for the introduction, we are required to design a refrigerated container, which is contain a frozen food to be uh, bringing to from Johor Bahru to Kuala Lumpur. So the container have consisted a two-layer material, which is insulator and the metal sheet. And we use ice box, dry ice as the material for cooling the container. So for the next, we are using chapter 2, which is heat conduction. And for the insulator, we need thermal conductivity can be found in the table. So next is the thermal conductivity of this problem. We are using the multi-layer plane walls problem with the convection of heat transfer between the surface of the material and the outer surface of the material. So in equation 1.1, showing the convection heat transfer equation. So next, we are also using the knowledge at chapter 7, which is external force convection. We were using the problem of the flow over flat plates. And the critical Reynolds number is 500,000. And we will need to decide either it is laminar flow or turbulent flow. So next is the design specification. As we can see, the truck container or refrigerated container, which is 6 by 3 by 2.5 meter. So the flat plate on the top of the surface, and we assume the velocity of the truck is 90 km per hour with the outer temperature 38 degrees Celsius, and we place the dry ice in the middle of the container. And as we can see in the picture, I drew a cross section of the material which having a certain thickness for the metal sheet and the insulator. That's all for me. Thank you.
So now I will explain the details of the properties that we use in our calculation for this project. So for the K for method of the lorry and dry ice container, we choose alloy 2024 T6 with a value of 177 watt per meter Kelvin. And for the K value and the density of insulator for the lorry, we choose urethane 2-part mixture rigid foam, where the K value is a 0.026 watt per meter Kelvin and the density is 70 kilogram per meter cube. For the CP of dry ice, as we searched in the internet, we found that the CP for the dry ice is 571 kilojoule per kilogram, and the density for dry ice is 1,700 kilogram per meter cube. After that, the thickness that we assume for the both material that we choose is the when with the alloy 2020 46, we assume around 0.05 meter, and the urethane to pulp mixture rigid form is 0.1 meter. So next, I will explain about the assumption that we use in this project. The first one is the top container is idealized flat plate. The second one is the average velocity of the truck is 90 km per hour due to Malaysian high speed limit. The third one is the property of specific heat capacity of dry ice are constant. As I said earlier, that we Google and search in the internet, and we found out that the value is 571. Next, we assume the duration of one trip is around 6 to 5 hours, 5 to 6 hours, but we specific to 6 hours, include the rest times, tolls, and traffic jams. Next is we assume the dry ice box inside the lorry container is in cube shape. And lastly, we neglect heat transfer at dry ice container.
Hello, Assalamualaikum. So next is the heat analysis. Since the temperature given is 38 degrees Celsius, but at the table there is no the specific 38, so we will need to use interpolation. So for the first interpolation, we will need to define the value of K, pressure number, and the kinematic velocity. So using the interpolated data, we will need to find the Reynolds number using the following formula. And using the following formula, we have get the our Reynolds number is 8.91 times 10 power of 6. Since the Reynolds number is more than the critical Reynolds number, we had decided that the flow is turbulent flow. So therefore, we will use the formula for the Nusselt number for the turbulent flow, which is 0.037 times Reynolds number of power of 0.8 and pressure number power of 1/3. So next, by using the formula, we can find the Nusselt number for our analysis. That is 12,073.01, and using the Nusselt number, we can use to find the H, which is 53.27 watt per meter squared Kelvin. Next, we will need to find the heat transfer using the formula HA times T infinity minus T surface. And using the formula, we get that our Q for this analysis is 133.6 kilowatt. So to find how much kilogram that we need, we will need to use this formula, which is Q over CP. So using the data, we get that we will need 0.234 kilogram per second for the dry ice. So using the assumption that we assumed earlier, which is 6 hours per trip, we found that we need 5,054.4 kilogram per trip. So by using the cost of the dry ice, which is 6 ringgit for per kilogram, we found that the cost of per trip is 30,326 ringgit point four. This analysis is for when we assume that there is no insulation. So next is when we added insulation into the analysis. So for this analysis, we have as we explained earlier, we have used the alloy and the urethane as our insulator. So we will use the chapter 2, which is the thermal conductivity. So first we will find the conductivity resistance for the alloy for the temperature outside, which is we get 2.844 times 10 power negative 4. Next, we found the resistance for the alloy, which we get 4.28 times 10 power negative 6. So for the urethane, we get that the resistance is 0.0583. It is bigger compared to the others because it is said that it is a good insulator. So the total resistance that we get is 0.05856. Using the resistance, we can get the heat transfer for this analysis, which is 600. The previous formula, we can get the amount of dry ice needed for a trip, which is 24.55 kilogram per trip, and the cost is only 147.27 per trip ringgit Malaysia. So when comparing the without the insulator and with the insulator, the reduced percent that we get is 99.51%. It is quite big. So for the next is we want to find the dimension for the dry ice container using the basic formula, using the density of the dry ice to find the volume for the dry ice. So we found that the volume is 0.0144 meter cube. And after calculation, we have found that the dimension is 243.52 mm. But for safety precaution, we take it slightly bigger. So we have decided that our dimension for the dry ice container is 250 mm. So that's all from me. Thank you.
So next, I will try to explain a little bit about this project, where in this discussion is all about explaining about the analysis before, and the one that I want to try to discuss is about the comparison or the difference between if there any insulator or not. So as we see above, there's a huge gap difference between the price for if we include the insulator or not. If we see that if we not include the insulator, the cost for per trip is around 30,000 ringgit, while for if we include the insulator, it's only around 147 ringgit. It shows that if we include the insulator, it will reduce a huge amount of cost that will make the per trip cost is very cheap. So I think the insulator is a must for the lorry to be inserted into the lorry. So next, I think there is another method that we can improve in our design or system based on the project that we know that this lorry have to transport the ice from Johor Bahru to KL. And I think the improvement that can be done is that we can add a circulation system inside the lorry where it can control the flow of carbon dioxide that been exerted from the dry ice, because as we know that dry ice is made of carbon dioxide. So if we make the circulation system inside the container, it will control the air within the container. Next, we can also ask the company to raise a factory in Kuala Lumpur, which is more sustainable as it will reduce the time to transport. This will make there is no time at all for the dry ice to be transported. So I think that's all for this project. So that is the reference for this project and the appendices where we took the value from the table A6 for the urethane two-part mixture rigid foam. As I stated earlier, the density is 70 and the thermal conductivity is 0.026. And then we took the properties for alloy 2024 TC at table A3. And also we refer the data for the air, which is the 38 degrees, where we took the data from 35 degree and 40 degrees. And I think that's all from us. Thank you.